Tech ecosystems are constantly building higher walls to protect users from malicious software. But as those walls go up, everyday users are finding themselves locked out of their own devices. Take Android's recent sideloading rules. To install a third-party app, users are forced to navigate Google's advanced flow, which mandates a 24-hour waiting period, or they have to manually push the installation via the Android Debug Bridge, a command line tool known as ADB. Power user Robert Triggs got tired of remembering exactly where he put his executable files and pasting file paths into terminal windows. He decided to build a dedicated automated app to handle the entire installation workflow for him. In the tech industry's rush to enforce absolute security, platforms have introduced layers of friction that punish power users, leaving them desperate for workarounds. Robert had a full-time job, 2 kids, and 0 experience with Go, the programming language he wanted to use. To get it done, he turned to AI-assisted vibe coding. You can't just hand a complex prompt to a model like Anthropic's Claude or OpenAI's Codex and expect a finished application. Simply asking an AI to build an app usually traps the user in an exhausting loop of broken code. Getting a functional result requires breaking the project down into sequential phases, planning the architecture, building the components, reviewing the logic, and tweaking each step alongside the AI. These models serve as capable execution engines, yet they require a human at the wheel to reach a functional finish line. Robert didn't start the process by typing a prompt or generating code. He started by manually building the physical boundaries of the project. He created the specific folder structures, laid out a few placeholder functions, and set up a .gitignore file to define exactly where the application lived. Then came the most critical step, writing the agents.md file. This plain text document dictates the project's exact requirements, overall goals, and coding constraints before the AI is allowed to write a single line of logic. With the scaffolding locked in, Robert paired his standard code editor with a $10 subscription to specialized models like Minimax M2.7, bypassing the high costs associated with premium AI agents. If you fail to lock down the environment manually beforehand, the model will hallucinate features and break the logic of your software. The first developmental milestone was commanding the AI to build a foundational wrapper for the Android Debug Bridge. This background code handles device discovery, connecting the computer to mobile phones to push APK files over Wi-Fi. Next, they layered a terminal user interface, or TUI, on top of those commands. Robert instructed the AI to use a framework called BubbleT, making the command line process visual and easily navigable. To manage the back and forth, he used Git version control to rewind the inevitable mistakes. He also had the AI expose the interface theming in a simple configuration file, allowing him to manually tweak the colors without spending AI credits on small design adjustments. In 3 days of off-duty work, this process produced the Tiny APK Installer, a fully functional 7-megabyte cross-platform executable containing roughly 3,000 lines of Go code. Applying strict human guardrails to the generation speed of a language model yields reliable code in a fraction of the time it takes manually. The Tiny APK Installer successfully pairs with devices and unpacks bundles, but relying heavily on an AI agent to build it created a quiet personal deficit. Because the model solved the micro-problems along the way, Robert missed the opportunity to deeply learn the Go language's syntax and logic patterns. He had a finished app, but he still couldn't confidently write in Go. This knowledge gap became alarming during a manual code review. The AI had quietly generated a zip-slip vulnerability, a flaw where an unpacking archive file can trick the system, bypassing its safe folder to overwrite critical files elsewhere on the machine. When you outsource the logic of your application, you outsource your understanding of how it actually works, leaving you blind to structural vulnerabilities sitting hidden in plain sight. In a local app installer, a zip-slip bug is relatively harmless, but if this software were handling API keys, secure credentials, or encryption, that AI-generated flaw would have compromised the entire system. The role of the human in software creation is shifting. Memorizing syntax and typing out functions is no longer the primary job description. The developer must now step back and act as the project manager, the structural architect, and the ruthless security auditor, looking for fractures in the code the machine builds. AI has automated the act of building software, which means humans must now work twice as hard to ensure those creations don't break the systems they were built to improve.